So howdy everybody. So the last time we left off, we were talking about the ramifications of systemic risk and what return theoretically should we calculate based on systematic or systemic. It's pronounced either way, right? Risk only. And so we're going to look at that now with the capital asset pricing model. Okay, so basically, which of the risks of a stock are likely to be firm specific, right? Diversifiable, and which are likely to be systematic risks, right? So the choices here: the risk that the founder and CEO retires, the risk that oil prices rise, increasing production costs, the risk that a product design is faulty and the product must be recalled, and the risk that the economy slows, reducing demand for the firm's products. So basically, because right, oil prices affect everybody pretty much equally, and the health of the economy affect all the stocks. So B and D, right, the oil and the health of the economy are systematic, and the rest are basically firm specific, right? The CEO retiring and blah blah blah. You can diversify out of those problems, right? That's basically easy to do. So everyone should be clear about that, right? Or basically a coronavirus affecting the whole world. Okay, so to measure the systematic risk of a stock, we got to determine how much of the variability of that stock, right, the risk itself, is due to the systematic risk and how much is due to the unsystematic risk, right? So we have to look at the average change in the return for each 1% change in the return of a portfolio that fluctuates slowly due to systematic risk, right? So we're concentrating here on systematic risk, and the capital asset pricing model will come soon. So what's an efficient portfolio, right? An efficient portfolio is one that you're diversified out of any unsystematic risk. You're well diversified, and you only have to worry about only systematic, and you don't have to worry about any unsystematic risk, right? You're well diversified. And we look at a market portfolio, and we're going to use a market portfolio as a reference. And the market portfolio that is normally chosen is the S&P 500, and that's often used as the standard as the market portfolio. Okay, so we're going to do that, and what you're going to find is the capital asset pricing model is a very simple equation to use. Okay, and the other thing we have to do now is define, and a lot of you people should, if you don't know this, if you're ever going to buy a stock, you always have to look at the beta of a stock. All right, so beta of a stock is a little different than volatility. Volatility measures total risk, right? The systematic plus the unsystematic. And the beta is simply a measure of only the systematic risk. So the beta is why you'll see that in the capital asset pricing model. So, this is an important item, right? So let me highlight that, all right? Let's do that, because that's an important concept. We're splitting up now the unsystematic and the systematic risk. We're getting rid of that, and we're going to just do. All right, hold on. Let me get this. All right, so we have a market portfolio, and it increases by 47% when the economy is strong, and it declines by 25% when the economy is weak. So what is the beta of a type S firm whose return is 40% on average when the economy is strong and minus 20 when the economy is weak? What is the beta of a type I firm that bears only idiosyncratic or firm-specific risk? Okay, idiosyncratic means firm-specific risk. Okay. The systematic risk of the overall economy, right, is going to produce a 72% change in the return of the market portfolio, and we went from the high and we subtract off the negative 25. So overall, it's a 72% change. So the type S firm's return changes by 60% on average. So the beta, how do we get the beta? The beta is simply the 60% on the company itself divided by the 72% return on the market portfolio. So the beta of that particular stock is 0.833, right? So that's how you get the beta, okay? That is, each 1% change in the return of the market portfolio leads to a 0.833% change in the type S firm's return on leverage. Now, because there's no, the only thing we got to worry about with firm I, it has only firm-specific risk. Now, I don't know why it would only have that, but that makes the beta equal to 0, all right? So it's only affected by factors specific to the firm, but I've never seen a company that really would be like that, all right? The only one I could think of maybe recently is Amazon has seemed to be doing well. Amazon is doing well considering the shape of the economy, because I think a lot of people are shopping online. So you can see here the beta is 0. All right, so what happens if the market portfolio tends to increase by 52% when the economy is strong and decline by 21% when it's weak? And all they did was change some numbers, right? This is the same exact problem here, and all they did was vary some numbers, okay? So you can clearly see here, you can go through this again and calculate the beta, okay? You get the beta right there, right? And so it'll lead to a 1.02% change in the type S firm's return on average. Okay, so that's really all you have to know. And for the type I firm, it's going to be 0. All right, again, it'll be 0. Okay, so here's a good table from your book, and you can, if you buy a stock, you should look up the betas. Here's a bunch of the betas for a bunch of companies, right? And the larger the beta, the more volatility the price will be. You can see here that for utilities that have a very small beta, they don't fluctuate much because they have a pretty much steady stream of revenue. Now you'll see betas don't stay the same. Betas change over time. So look for betas to really change after this whole economic problem we're having in 2020. So you'll see the betas of stocks because stock prices have really fluctuated with all the volatility. Okay, so you can clearly see, and you can see the home furnishings and kind of like luxury, I'll call them, goods, right? They kind of change a lot. But there's even more, like a lot of internet stocks will have betas above 1. So, but it's always good to understand and know about a beta of a stock before you buy it. So here's some more betas. And you can see here, Microsoft has got a beta above 1, and Google does, and so the betas vary, and they will never stay the same. So don't ever think a beta is going to be the same for a stock. All right, here's a bunch more. You can see now they go up and higher, and they tend to just keep rising. Okay, here's Amazon now. Look, with a beta of 1.62, and AMD, if there's no market for chips, integrated circuits, and microprocessors, they'll fluctuate a lot. So you can clearly see, and if people aren't buying furniture like from Ethan Allen, all right. So so the betas of a stock are important, and they will swing. Whoops. All right. So here I was. So a security's beta is related to how sensitive its underlying revenues and cash flows are to general overall economic conditions, right? So basically, you determine the return you require on a stock based on the beta, based on the current economic cycles, all right? So depending on this industry we're in, cyclical are likely to be more sensitive to systematic risk and have higher betas, as we just saw, okay? So, that's important. Okay, so here is the market risk premium. The market risk premium is the reward investors expect to hold for a portfolio. So here's the market return, like the return on the S&P, minus the risk-free rate. And again, you notice this is for a beta of 1, right? So the market risk premium, it was if they held the S&P 500. So the S&P 500 will always have a beta of 1. Okay, by definition, don't ever forget that. The S&P 500 has a beta, and everything is referenced to that. All right. So that I just want to make sure everyone's clear about that. Okay, so here is the capital asset pricing model. So adjusting for beta, all based on systemic risk. Okay, so your expected return on a stock is equal to the risk-free rate plus you take the beta and just take the risk premium we talked about here and simply basically multiply these together. So this is the risk premium. The risk premium is this whole term right here, the beta plus all of this. You see how it's written. Risk-free interest rate is here, and the risk premium is all of this times the beta, okay? So that's the capital asset pricing model. You can clearly see all you do is plug in the risk-free rate, the beta, the market portfolio return, and again the risk-free rate, and you're home free. The math is trivial. So here's an example. I want to just show you an example. This is going to get large, but I'm going to show you an example. So here's a simple example of how to calculate the risk return required on a stock with a beta, and they give you all the numbers here. So here's the beta 0.833. Here's the risk-free return. Here's the market portfolio return, right? So 11 minus 5 is 6 times this number plus 5, and you'll get the return on stock is 10% based on the volatility of the undiversified volatility, okay, that you can't get rid of. So that's all you've got to do. So that's all that's really important, is how do you determine what you require on your return based on undiversifiable risk that you can't get out of. Okay. Okay, so here's another example using Microsoft with that, right? So here's Microsoft. And here's how they do it. Again, they just pop a couple numbers in. This is an important equation. So remember, it's the capital asset pricing model. So as I said, here it is. So let me highlight all this. So it's the most important method for estimating the cost of capital used in practice, okay? So, all right, so that's it for this chapter. And, okay, that's it. I'll post this.